Imagine this moment. A US Navy destroyer is sailing through the narrow waters of the Persian Gulf. The radar screens inside the ship's combat information center suddenly light up with multiple contacts approaching at high speed. The warning alarms begin to sound as operators shout out coordinates. Within seconds, the crew realizes what is happening. A salvo of anti-ship missiles has just been launched. Somewhere beyond the horizon, enemy launchers have fired weapons designed specifically to destroy warships. These missiles are flying just meters above the ocean surface, approaching at supersonic speed. The question is no longer theoretical. Can the ship stop them in time? For decades, military analysts have debated one question that keeps appearing whenever tensions rise in the Middle East. Could Iran's missiles actually sink a US Navy destroyer? On paper, the United States possesses one of the most advanced naval defense systems in the world. But Iran has spent years building an arsenal designed to challenge exactly that kind of dominance. So what would really happen if those missiles were fired? Could they overwhelm the defenses of a modern warship, or would they be intercepted long before they reach their target? To answer the question, we need to examine both sides of the equation: the missiles Iran might launch, and the incredible defensive systems protecting one of the most advanced warships ever built. Chapter 1: The Power of a US Navy Destroyer. To understand whether a destroyer could be sunk by missiles, we first need to understand what kind of ship we are talking about. The backbone of the modern US surface fleet is the Arleigh Burke-class guided missile destroyer, a warship designed to operate in some of the most dangerous environments on Earth. At more than 150 meters long and displacing nearly 10,000 tons of steel, these ships are essentially floating missile platforms capable of defending entire fleets. Their mission is not just to fight enemy ships, but to protect aircraft carriers, intercept incoming missiles, track submarines, and even strike land targets hundreds of kilometers away. At the heart of the destroyer's defensive capability is the Aegis Combat System, one of the most sophisticated naval defense networks ever developed. The system integrates radar, sensors, computers, and missiles into a single battle management system that can detect, track, and engage dozens of threats simultaneously. The ship's powerful SPY-1 radar scans the sky and ocean in every direction, constantly monitoring for aircraft, drones, and incoming missiles. In fact, these destroyers are capable of tracking more than 100 targets at the same time, calculating trajectories in real time, and automatically assigning weapons to intercept incoming threats. The ship's vertical launch system can carry dozens of missiles, including the standard missile family designed to destroy incoming aircraft and missiles at long range. But despite these advanced defenses, the reality of modern naval warfare is that no warship is completely invulnerable. Every defensive system has limits, and that is exactly where Iran's strategy begins. Chapter 2: Iran's Missile Strategy. Iran understands that it cannot compete with the United States Navy in a traditional naval battle. The US fleet is larger, technologically superior, and backed by global logistics and satellite networks. Instead of trying to match American power ship for ship, Iran has spent decades developing a different approach. This approach is known as asymmetric warfare. Rather than building massive fleets of warships, Iran has invested heavily in weapons designed specifically to threaten high-value naval targets. Among the most important of these weapons are anti-ship missiles capable of striking ships far out at sea. These missiles are launched from coastal batteries, aircraft, submarines, or mobile launch vehicles hidden along the coastline. One example is the Khalij Fars missile, an anti-ship ballistic missile derived from the Fada 110 family. It is believed to have a range of roughly 300 kilometers and is designed to strike moving ships using terminal guidance systems that adjust the missile's trajectory during its final approach. Another system reportedly developed by Iran is the Abu Mahdi anti-ship missile, which Iranian officials claim has a range of up to 1,000 kilometers and advanced guidance systems designed to target naval vessels. But missiles alone are not the entire strategy. Iran's doctrine emphasizes layered attacks, combining multiple types of threats simultaneously. Cruise missiles may approach at low altitude to avoid radar detection. Ballistic missiles could descend at extremely high speeds from above. Drones might be launched at the same time to distract defenses, while fast attack boats swarm around the target. The goal is simple: overwhelm the defensive systems of a warship by forcing it to deal with too many threats at once. But here's where the situation becomes even more dangerous. Imagine not just one missile approaching a destroyer, but 20 or 30. Military planners refer to this as a saturation attack, a coordinated barrage of missiles and drones designed to overwhelm even the most advanced defenses. If enough missiles arrive at the same time from multiple directions, even a sophisticated system like Aegis could be pushed to its limits. So the real question is not whether a single missile could sink a destroyer. The real question is what happens when an entire wave of them arrives at once. Chapter 3: How Destroyers Defend Themselves. Despite the threat of saturation attacks, U.S. Navy destroyers are designed with multiple layers of defense. The first layer begins hundreds of kilometers away from the ship itself. Radar systems detect potential threats long before they reach the fleet, giving commanders time to respond. Long-range interceptor missiles like the SM-2 and SM-6 can be launched to destroy incoming targets far from the ship. These missiles are capable of intercepting aircraft, cruise missiles, and even some ballistic missile threats. If an incoming missile penetrates this outer layer, a second layer of defense becomes active. Medium-range interceptors, such as the evolved Sea Sparrow missile, are designed to destroy threats that are closer to the ship. These systems are specifically optimized to intercept sea-skimming missiles flying just above the ocean surface. But even that is not the final layer. If a missile manages to break through both of those defenses, the ship still has point defense systems designed to protect it during the final seconds before impact. One of these systems is the Phalanx Close-In Weapon System, a rapid-fire Gatling gun capable of firing thousands of rounds per minute to destroy incoming missiles at extremely close range. In other words, before a missile can hit a destroyer, it must survive multiple defensive layers designed specifically to stop it. Chapter 4: Could a missile actually sink the ship? Even if a missile successfully hits a destroyer, that does not necessarily mean the ship would sink. Modern warships are built with extensive damage control systems designed to keep them afloat even after sustaining heavy damage. Their internal compartments are divided into watertight sections that prevent flooding from spreading throughout the entire ship. Fire suppression systems, redundant power supplies, and trained damage control teams all work together to contain damage and keep the vessel operational. Historically, it has often taken multiple hits to sink a modern warship. Even ships struck by powerful anti-ship missiles have sometimes survived due to effective damage control and structural resilience. However, the danger remains real. A successful missile strike could disable critical systems, damage radar equipment, or start fires that threaten the crew and the ship's combat capabilities. Even if the ship does not sink, a heavily damaged destroyer could be forced to withdraw from the battlefield. And that alone could represent a strategic victory for the attacker. So could Iran's missiles sink a US Navy destroyer? The honest answer is complicated. It is extremely difficult to penetrate the layered defenses of a modern destroyer. These ships were designed specifically to survive in missile-heavy combat environments, and their defensive systems are among the most advanced in the world. But in warfare, absolute guarantees rarely exist. If enough missiles were launched at once, if multiple systems were combined in a coordinated attack, and if even one missile managed to slip through the defensive shield, the results could be catastrophic. This is exactly why naval strategy in regions like the Persian Gulf is so delicate. Every destroyer, every missile system, and every radar signal becomes part of a high-stakes technological chess match between two very different military doctrines. And as long as tensions remain high in these waters, the question of whether those missiles could ever strike their target will remain one of the most serious concerns facing naval planners today. Because in modern naval warfare, sometimes the most dangerous battle is the one that never happens.